Hey, hello, welcome to the show. It's me, John Park. It's time for John Park's workshop. Here we are in my workshop, and here we are in the Wednesday time slot, which I've been doing for a few weeks now. It's not my normal slot. Usually I'm on Thursday, but I've been right here in this time zone and helping out while PT and Lamore are off doing other stuff. I'm just going to have a sip of delicious water. There we go. So hey, thanks for stopping by, and let me know in the chat how the stream is, because I was seeing some stuttering and stuff during the intro there, and I am crossing my fingers that it works itself out. I'm also going to reopen the YouTube chat because that window got funny. Oh, hold on one second here. Here we go. Pop out chat. So where's the chat, by the way? If you're wondering, I'm checking the YouTube chat. I'm also over here in our Discord. So that is over at adafruit.it/Discord. And then you'll want to look for the live broadcast chat channel. And that's where people are hanging out. This is it. This is what it looks like right here. That's our chat. Oh, good. Stream is fine. Okay, I think I'm having some issues that are just with playback, hopefully. Here, and not, boy, I'm very off to the side, and nothing to do, hopefully, with streaming, so that would be good. So, yeah, there's a helper. Who noticed that? There's a little helper back there, a little merry little Lars Claus or something. I don't know what his proper holiday name is. Hi, James Freeman, thanks. Good stream. All right, good. Our quality... So far, so good. I don't want to jinx it, so I'll knock. Hi, George Graves, and hello to all the people in the chat. Lots of people coming to join us. So let's see. First of all, I want to mention that I've got a coupon code for you. So if you want to get some stuff over in the Adafruit store, and you'd like to save a little bit of money on it, you're not going to get it in time for Christmas. That ship sailed, I think, on the 19th. But you can still get stuff, for sure. And this is your coupon code today, Kringle. Kringle, Kringle. That is going to get you 10% off over in our store. Just throw the stuff you want in your cart, and then on the way out, look for the coupon code field. Type in Kringle, and that'll get you the 10% off. That is good on physical goods. It's not going to work on software or subscriptions or gift certificates, but it will work on stuff. So go get yourself some stuff. Also, you should know that we have some different freebies, tiers of freebies, and I believe at the $99 tier, right now we're doing a free nude, one of our little flexible noodles, LED noodles, and then, in fact, I'm gonna, let me open up my, where is it? Let me pop open the Chrome page that'll show us that. Hold on. There we go. So here, if we go to adafruit.com/free, just type that in, /free, and then you can see what all of the different discounts you can get are. So there you can see them. There's a nude, there's a KB2040, there's a tiny UPS truck, and there's a Circuit Playground Blue Fruit. So $99 or more, you get the free nude. $149 or more, you get the KB2040 keyboard, perfect for all of your keyboard projects, MacroPad projects, and more. $200 or more, you get the free UPS ground shipping in the continental United States only, sorry. And then for orders over $299, you get the free Circuit Playground Blue Fruit. All of these stack, so you'll get all of those things. If you go past the $299 mark, you'll get all of those things below, and that'll get you some fun free stuff. And we appreciate your support, because that's how we keep doing what we do here at Adafruit, is by having you go and buy stuff. And that right there, that is the coupon code that's going to get you 10% off today, and that's good during the show and till around the end of the day. Maybe a little sooner, maybe a little roughly around midnight East Coast time, I think. So what else is going on? Hey, we had a show and tell right before this show. You may have seen it. That happens every Wednesday night at what, 7:30 Eastern time. It's 4:30 Pacific time. And on today's show and tell, here's what we saw. You can go back and check it out, by the way. All of our shows are archived. You can just head to maybe some of the other places, but definitely YouTube. I think Twitch archives stuff. But if you head over to YouTube, you can see the past episodes anytime you want. Jeff Epler, our own Jeffler, showed his Next mouse. So Next brand computer. He had taken the Next keyboard a few weeks ago and managed to figure out how to get it to work on a modern computer by reading its bits into a QT Py and then sending out USB to a modern computer. And now he's added to it. He got a somewhat rare Next mouse and figured out the protocol for that. It actually passes through the keyboard. Keyboard has a little DIN port where you plug in the mouse, and then both keyboard and mouse info is coming out into the QT Py through his cute little adapter 3D printed case, and then off into modern USB land. So he showed that off, and Noe and Pedro came on. They showed the scrolling countdown timer. This is a really nice countdown timer that scrolls text and numbers across to let you know how much time you have left until a big event. It uses 3 of the 14 segment displays, alphanumeric displays, as well as a QT Py ESP32S2, and it is using Adafruit I/O to go up on that internet and grab the time, and then you can code it to count down any event that you like and give it text for that, and then it checks all the time to make sure that you are keeping time properly. DJ Devon came on and showed 3D printed caps or actuators for the step switches, and he has been on a mission to get orange keys because he wanted to make a Roland style, 808 style sequencer, and orange keycaps are not available for those step switches. At least we haven't found any, and Adafruit doesn't sell any, but he's done a whole bunch of work on refining the 3D model for that so that they'll work, and you can print them in any color you like, and you can go and get the step switch caps, I believe, in the CAD repo on GitHub, on the Adafruit GitHub repo. So I'm going to go look for those. That's very cool. Thanks for showing that. And he also showed the first project that he's using those on, which is the Cowbell, TR Cowbell, and he actually sent me one. I've got it right here, and there's no orange switches on this one. This is all the stock switches. But this is a project I'm going to play around with and show more of in the future, but it is a step sequencer, similar in some ways to the one I've been working on for the 16-step sequencer, but on a really cool custom PCB. In fact, let me show off DJ Devon's PCB a little more. It's upside down. It's upside down. So really clean looking, some really nice logos and graphics on there. And check out the back. We have Christopher Walken and Will Ferrell doing their cowbell sketch, Louis Stricult cowbell sketch from Saturday Night Live, as well as some Adidas stripes on there and a whole bunch more. So that was show and tell. What else? Mark Gambler. Mark Gambler was live streaming from a phone, I think, and walked outside into the negative 20 degrees Celsius weather. He immediately shattered into 2,000 pieces, but being Canadian, he was able to reform just like the Terminator does from mercury blobs, gird his loins, tough it out, and the reason he did all that, not just to show his dedication and his tough Canadianness, but he was able to show us his window display. Actually, he's got 2 window displays for the holidays, using some NeoPixel strips around the window, some small tree lights as well as a tree topper. And then he's got his second window, which is using a bunch of NeoPixel strips combined into a display, into an animated display. And he also mentioned that he's looking forward to the Scorpio board because in his first window display, he showed those were all separate microcontrollers for the different NeoPixel strips, and the Scorpio will help with combining that into a single microcontroller, which is super cool. And then, that's not all the Jepler that we get. We got extra Jepler at the end. Jeff Epler came on to show and tell a really great looking robotics magazine from 1985. That was a Robot Experimenter magazine. A bunch of robot arms in there, a full schematic of 8 pages of schematic for building your own computer from scratch, as well as a neat little robot that used a type of disk encoder to let it know when to turn which wheels, a primitive form of programming it, which is pretty cool. A form that dates back to a Leonardo da Vinci robot pretty much too, if you ever look up the little cam, programmable cam-based cart robot that da Vinci designed. Similar idea. And that was Show and Tell. So thanks everyone for coming on. And if you want to show stuff on Show and Tell, just stop by any Wednesday night at 4:30 Pacific time, 7:30 Eastern time. Go to our Discord and you will find a link right before the show starts. You'll find a link and you can click on that and head over to our StreamYard where you'll get in and be able to show your stuff. Let's see, what else have we got going on? Let's see. How about this right here? So CircuitPython is Code Plus community, and one of the ways that we celebrate that is with our newsletter, the Python on Microcontrollers newsletter. Let me bring that up, the newest issue, so you can have a look. So you can sign up for this at adafruitdaily.com, and you'll get a new one in your mailbox every week. It's not a daily, but we call it that. But it's the weekly Python on hardware, or rather Python on microcontrollers. And there were a bunch of great articles in here. I will just skim through it a little bit and mention a few, but you can go sign up for it. If you go to Adafruit Daily, right at the top, you can find a link to this week's edition of the microcontroller, Python on Microcontrollers newsletter. I gotta come up with a way to remember that name. Important first article in here, the Mac OS Ventura operating system has a fix in that corrects some of the problems that were involved with dragging and dropping onto UF2 devices, or dragging UF2 files onto drives so you could flash your microcontrollers like we do with CircuitPython, and there are other cases where this happens. Lots of devices use this now. That's been fixed, so that's great. It says it is not perfect. There are still some cases where things are flaky, so read the article for more. But if you've been holding off, as I have, on upgrading, primarily due to this bug, then good news, it's getting fixed. The PyLeap update, we've got a big update on PyLeap. And one of those is now we have Wi-Fi transfer working. So being able to send code over to a microcontroller via Bluetooth, we had that working. And now with the new update, you'll be able to do that with Wi-Fi based devices as well. There's an example there showing one of the Feather boards doing that Wi-Fi connection. Then let's see some other articles. I'm not going to go through everything. There are a bunch of fun projects in there, some Maker Advent projects. There was an R2-D2 made with a Raspberry Pi Pico and a servo for rotating the head, created in MicroPython. Let me scroll down to that. That one was cool looking. There's a cute Mario star up on the top of a tree. Some more of these Maker Advent projects. There we go. There's the little R2 there. Looks like made from cardboard. I've not gone and checked that out on Twitter, but that was a MicroPython project there. It looked pretty cool. Also saw this one, the RP2040 Stamp console is this tiny little, super teeny tiny little game console, which is a Flux preview product, and it is going to support Arduino, CircuitPython, and experimentally Arduboy games, which looks like a lot of fun. Also saw there was a Lego case and a RPi Pico combined with a gutted old MIDI controller or keyboard of some kind. This keybed here is now able to send out MIDI, so beautiful looking build on that. Go check that out, link on Twitter. And the last one I saw on here that I wanted to mention was this project that turns the radio volume down for advertisements and DJs talking for a Sonos speaker using Soco CLI Python library when TuneIn is being used. So go check that out to find out how to have automatic volume reduction for ads, which is great because ads always crank it to the maximum volume, which is disconcerting. So those are some of the great things that you'll find in the Python on Microcontrollers newsletter this week. And thank you so much to Anne for putting that together along with other contributors. All right, let's see what else is going on. Hey, let's talk about the return of AdaBox. So we were unable to put out AdaBox during 2022 due to the global parts shortage, but we've been hard at work getting ready to release AdaBoxes on our much more regular schedule during 2023. So head to adafruit.com/AdaBox to find out more, to sign up, to get on the list to subscribe. We, I think, are generally in the pretty darn full for the next one, but people do drop off, so add yourself to the list and you might be able to get on even if it looks like the next one is spoken for. And you can also subscribe other people as a gift. It's going to be a lot of fun. I'm looking forward to these. We have a bunch of really cool things planned for AdaBox in 2023. So I hope you will come along for the ride. It should be a lot of fun. Let's see, what else I want to mention. How about Learn Guides? So let me jump over here. The Adafruit Learn system has loads and loads and loads of tutorials, which you may know. It's a great place to go and find out how to use something or look for inspiration in a project or just look at a direct tutorial, direct instructions on how to build something that looks neat. If you've seen something that one of the Adafruit team members have shown here on social media or on Show and Tell, there's a really good chance that there's a Learn Guide in the works. So usually you can head right here to the new guides page and you'll see all the new stuff. We actually had some updates, some guides, just some small bits of code that based on a change to the .env file that moved some things into here. So not all of these are new, but I have a little list so I know which ones to mention. So first of all, I'll say NeoPixel Sprite Weather Display by Liz Clark. This one is a really minimum viable weather display, but it really works. You can see from the GIF there, it scrolls across the temperature, and then it uses these really cute little 5x5 pixel icons that Liz created to show the weather. So you can see cloudy, sun coming out, stormy, all of the typical weather icons. And this uses Adafruit IO and grabs from, I think, weather.com or one of those, I can't remember, .org, maybe it's a .org, to get the weather in your area. Gives you all the code examples and also how to build this really cute cloud display case for it. I mentioned the scrolling countdown timer that the Ruiz brothers showed on Show and Tell. There it is right there, and that's a really cute photo of it there on the mantle. And this one's using the 3 sets of the alphanumeric, quad alphanumeric LED displays, and it can count down an event, let you know in days and hours, minutes, seconds, how long it is, in this case until Christmas is what they have it set for, but you can code that to anything that you want, any event you want to count down to. There was also a new guide called, here it is, the no-code DS18B20 temperature sensor with whippersnapper that Ava created, and this will show you how to set up this weather sensor and use whippersnapper so that you don't need to code it at all in order to be able to grab weather information, or rather temperature information, and display it on your dashboard. And then the last thing was the update, and this was one that I mentioned from the Show and Tell that Jepler showed the mouse. So this is a update. The guide was out, but now there's this page called Research 2 Mouse. And this shows you all of the info, research, existing links, new stuff that Jeff came up with in order to be able to query the messages coming from the keyboard that has the mouse plugged into it, to be able to grab both the keyboard and the mouse information, and then read that, get the button information, second button information, and then the X and Y axis information from the mouse, and then be able to translate that into USB. So those are the new guides, and like I said, there are also some updates to some existing ones that are just some code changes, so you'll see those in there. And those are our new Learn guides. DJ Devon 3 says, hey, having Pico in Whippersnappers, awesome, great job, Brent Rubel and team. Yeah, here. Fantastic. All right. Let's do a little bit of a, how about product pick of the week recap. So I have a show. It was yesterday. That's Tuesday. It happens every Tuesday. And it is called JP's Product Pick of the Week. And this week, it was the NeoPixel Driver BFF for Cutie Pie. This is the second NeoPixel-related BFF that we've had in a row. And on the show, I like to take a product, a new one, or an oldie but goodie, give it to you at a huge discount. This week, it was 50% off. Do a little bit of a demo, and here is a little 1-minute recap for you. It is the NeoPixel Driver BFF for Cutie Pie and Xiao boards. This gives you level-shifted 5-volt logic and a really nice easy JST connector for plugging in your NeoPixel strips. You just attach this to the bottom side of a Cutie Pie or a Xiao board, and you are off to the races, lighting up your NeoPixels. And so I just picked some color-matched headers there so that I could plug that in and know that everything was in the right orientation. So only can plug in one way. That's a keyed connection there. And then I'm going to simply plug in a USB-C cable. This is going to a powered hub on my computer. And you can see there, I'm lighting up some NeoPixels, lighting them away. That right there is my product pick of the week this week. It is the NeoPixel Driver BFF for Cutie Pie and Xiao boards. Yes, indeed it is. I'm just going to do a little thing here to see if I can convince my display to stop stuttering. That might work. Yeah, just let me know in the chat if you do see any issues with audio or video. Thank you. Let's see, what is next? Hey, how about a little CircuitPython parsec? CircuitPython parsec. All right, let me just get set up here, and I'm gonna get that camera. That should work pretty well. What I wanted to show you today on the CircuitPython parsec is how to scan the I2C bus for devices, particularly the device addresses. So when you're using these StemmaQT plug-and-play or other I2C devices, they all have an I2C address associated with them, and sometimes you might not know what that is. Sometimes it's written on the board, sometimes it's not, sometimes a complex set of jumpers have been updated to give it a particular address. If you just want to ask it, just want to say, hey, CircuitPython, just go tell me, what do I have on this thing? You can do it pretty easily. So first let me show you a little demo. I'm going to turn on my Pi Gamer right here. And you know what, I will zoom way in and refocus. And you can see here when I turn this on, it says I2C addresses found, and then it's just found one of them, so it's 19, OX19. That is the onboard accelerometer, I believe, that's on the Pi Gamer. So essentially I have nothing plugged into to my extra stemma slot there. So what I'm going to do is I'll turn that back off. You always want to turn off I2C things before you plug them, or turn off your microcontroller before plugging in I2C things. So I'm going to go and plug in a rotary encoder here. And now with that plugged in, when I turn this on, first thing it's going to do is it's going to go ahead and scan that bus, and now it finds two things. So it's added to that. Now we have this address OX38, so that is the rotary encoder there. The way this works is pretty simple. In code, you can see here, I have the board being imported, board library, setting up I2C, locking the I2C bus, and then this is the key here. I'm just in this one fell swoop. I'm printing I2C addresses found, formatting the device address to be a hex that we can read, print the hex in the print statement. And then the device addresses is the list of I2C.scan. So I2C.scan is the key here. It goes and it checks for any devices on your I2C bus. So if I want, I can go ahead and turn this off and add one more device here. I'll add another display, and you can see I'm not actually doing anything in code with these yet, but I just need to know their addresses so that I'll be able to set them up. So with these two extra devices plugged in here, I'll turn this on, and now it reads that we have addresses 19, 38, and 3D. And that is how you can scan the I2C bus inside of CircuitPython. And that's your CircuitPython parsec. All right. You know what? I saw in the chat, it was mentioned, let's see, that Kyoshi was saying I hot swap I2C a lot. If it works for you, I guess fine. I just tend to crash things when I do that. So I would avoid it. I hot swap a lot of things. I yank USB drives out like there's no tomorrow. I don't really believe them anymore. But the I2C, I have run into problems with that. Yeah, it's not hot pluggable. I believe maybe we had a product that was meant to help with that, but I don't think it works that great. I think maybe, I don't even know if we still have that. So pretend I didn't say that. Just don't hot swap your I2C stuff. Plug it in with things off, turn them on, and then have them be found. And if anyone has ideas on how to do that safely, let me know. But I think that's just really a no-no. All right. Let's see, what else have we got? Hey, let's talk about some. I'm going to do a little bit of a gear report. Actually, this should be a fun one. So let me jump over to the workbench here. And this is just something that I recently bought that I wanted to try out. I actually wanted to set it up live on air and see how it does. So let me set the stage for this. We have a really nice Dyson stick vacuum. We've had this for a number of years, and the battery is starting to get tired. It doesn't hold a charge very long anymore, and so I wanted to replace the battery. The battery is this, what is it, 4,000 milliamp hour? No, 2,800 milliamp hour pack, and it's a good battery pack. I would consider buying the battery pack that Dyson sells. It's like $128, but it's not cheap to get a well-made battery pack with good quality batteries in it and protection from thermal runaway, one that charges well. So you can find really cheap knockoff ones on Amazon, and a lot of people say these are kind of dangerous. I don't even know if I would trust them. I went ahead and got one, and it was dead on arrival. It wouldn't charge and it wouldn't work, so I sent it back. And what I got instead is a gizmo that allows you to adapt your existing portable tool batteries to use on the vacuum cleaner. So that's it. That's what it looks like. They are made for a particular brand of, or system, ecosystem of battery, depending on what you use. I have a lot of Milwaukee stuff. So just like the good batteries you could buy from Dyson for this thing, these are not cheap. I've gotten many of these with the tools that I got, but if you go and look, these are $100 or something like that to get, in this case, I think it's a 5,000 milliamp hour or 5 amp hour battery pack. So I have some big honking ones. I have some smaller ones. This one is the 9 9 amp power pack, kind of overkill for a vacuum cleaner. But I have chargers for these, a couple of them, and I have the batteries. Now I can't use the Dyson with the wall mount charger that it comes with. In fact, I'll just be pulling these off and charging them the way I always charge these. But let's have a look. So I've taken this off before in order to try that first battery I got. And basically, there's just 3 Phillips screws. And I'll mention they also have DeWalt, Ryobi, Makita maybe. I'm guessing name a battery ecosystem, and they probably have one that you can use. And like I said, I would have been happy to buy the very expensive Dyson one if it had been available, but it wasn't. And as it turns out, this solution, while not quite as good as having the standard that you can plug into your wall, it means that I'm not spending that much right now. This probably was $20-something for the little plastic adapter. And you can see all it really does. I think it has some LEDs that light up when you're using the device. And then it has a couple of these blade connectors for your battery pack to slide into. So I'm going to go ahead and plug this up into here. And I'll put a couple of these screws back. That's the big one back here. And I believe the factory ones run on, where did I put? That's weird. How did I just lose 2 screws? I thought I'd stuck them in my little magnet thing. I must have put them somewhere else. Oh, that's weird. I'll have to go back and watch the video to see what I did with those screws. Oh, I left them in this. I left them in the original battery. The device is running on a 21 volt system, 21.6. So my Milwaukee, which is 18, should mean that I'm getting a little less power. I'm not sure how major that really is. I think I have some DeWalt stuff too that is at 20 volts. That could be a better bet. But in most of the reviews that I saw online, no one was complaining that much about their vacuum power. And I do have more of these Milwaukee batteries, so I figured that would be a better bet for me, so I didn't have to go out and buy any new batteries. And this could just end up being a temporary fix for a year or however long it takes Dyson to figure out how to get new batteries into their store. So there you go. This now slides in. Can still use the little lock system there. And now I should be... Oh yeah! Let's see, we got a little light there, lighten up. The batteries have their own meter, so you can see the fullness back there, so it's fine that this doesn't tell me anything about the fullness. I'm not sure if that does anyway. So it's a little awkward. It's not going to sit the way it used to, and it won't go up on the wall like it would, so I'll have to probably pull that off and not have it charging. But anyway, that was, I'm not getting paid for that, or not endorsing any particular product. I didn't even know how well it's going to work. I haven't tried it that much yet, but I thought it was kind of an interesting thing out there in the world that I wanted to share, because I was like, hey, I've got good batteries that are pretty similar. Let's see how those work in the old vacuum cleaner there. Yeah, someone said that happened pretty quick. Yeah, it's dead simple to do. The earlier attempts at this, I think, were 3D printing projects. People were coming up with little adapters. But this is now in the realm of lots of people selling them for all the different major battery ecosystems. Actually, let's see what the giant one. I may even have one bigger. I can't remember. I think I have a portable band saw with a Milwaukee. That's a lot of vacuuming. I can't remember. I think you might get, I don't know, 20 minutes of the high suction. Max suction setting on the factory battery. This one is probably close to 4 times as much capacity than the factory one, which is pretty impressive. So. Oh yeah, Koyoshi says you can also get adapters to turn your tool batteries into battery banks. So yeah, I imagine getting something that gives me 5-volt USB off of those, you could charge your phone a bazillion times over, which is pretty nice. So, all right, so that's my little gear report there. I don't have a brand name or anything to endorse there. Like I said, I'm trying it for the first time, but if you just want you to know that it exists, I think it's a cool thing. I don't know if there are other devices out there where you wish you had a good battery and they also have this type of solution. I've pretty much only seen it for the vacuum cleaner, but it probably exists out there. Probably does. All right. So let's see. What else have we got up? So I wanted to talk about my LCARS project. So as you may remember, let me go to a Chrome view here real quick. Try to open that up again. Oh, actually, you know what? Before I do that, sorry, I just remembered. When I was talking about Learn Guides, I forgot. I wanted to mention also, speaking of Learn Guides, this is a really cool one that C. Grover from our chat posted on his user page. So we have the Adafruit user pages. I showed that Joey had done a guide here last week, I think, but Cedar Grove, Jan has posted this service guide for an old flanger pedal, guitar pedal, that had a 1980s era service manual available and not a ton else. So he was looking to repair one of these for a friend and decided to fully reverse engineer it and make CAD drawings and renderings in KiCad. Created a really nice looking block diagram of how the circuit works. Did some tuning of it and shows the adjustment procedure for that to really dial in the pedal, as well as here's all the different test points that you can use as you're testing the different voltages and signals. And then you can even, I think there's an out of print board, so you can, I believe, go ahead and make your own on OshPark. And I don't know if he's supplying, actually, I don't know if he's supplying that board or just the schematic. But so this is not really meant as a clone project so much as a really nice documentation of a vintage guitar pedal, flanger pedal. Really nice work. So glad to see people using the user pages for Learn Guides. That's a newish feature. And go check that out. You can just look for C. Grover in the Learn system, and then click on C. Grover's name. You can also go learn.adafruit.com/u for user /C. Grover, and you'll get access to any guides that he's put up there. So nice use of the user page, and really great work on that guitar pedal guide. So thanks for sharing that. All right, so on to LCARS. So you may remember this is a few months back. You can go to this Wikipedia on it. That's a good safe bet. LCARS is this computer system from the Star Trek Next Generations. And it has this distinctive graphic design style here. And a lot of these panels were essentially translucent vinyl print pressed to or adhered to a slightly smoky acrylic, slightly tinted acrylic, and then backlit. So just backlighting it gives you an easy way to put a whole Enterprise worth of, or whatever ship they're on, put the whole control panels up without a lot of high-tech stuff when this was originally created. Later, there were uses of light boxes with some polarizing film and rotating polarizing light filters to make the displays blink and do a little bit, and then it eventually became CGI stuff. But I have a friend who was working on a Star Trek show, got a LCARS panel and asked me if I could build a backlight display for this. And so I started to work on this, but I never had an accurate representation of the shapes. I started modeling it and using calipers, but really I needed to scan it in order to get close enough for what I need. So let me show you the panel here and what I'm trying to do. So this is the original panel. You won't see, let me try to get the glare off it. See, so I don't have a backlight on it right now, so you're not going to see too much, but we'll change that in a minute. So it is, you can see a vinyl sheet. You'll see some of the shapes in there from it being pressed and printed. But this is a very specific set of shapes, and so what I did was I got actually a free scanner from someone who was getting rid of one, just a cheap Canon flatbed scanner. Scanned this, was able to capture enough detail, it's a hard object to scan, that then I was able in Rhino to recreate the shapes. This is a little test laser cut I did just in some cardstock. And then I used some MDF to create a thicker, it's like a 3mm thick light blocker. And the reason is I needed this to match very accurately those shapes. So that now lines up exactly with those colored shapes there and numbers, so that I can project light behind it and not get bleed. And so you could, excuse me, you could always just throw a bunch of light behind this and it would look great. But I wanted to be able to blink light and have the full shapes turning on and off. And so with that light blocker and two of these pretty fine pitch LED matrices here and a matrix portal, I'll be able to light up some really specific shapes. So what I'll do, actually, I'm going to go over to the workbench and fire this up, and you can see what this is going to look like now. I can also vacuum some stuff if I want. It's kind of fun. So now that I have that light blocker worked out in CAD and Rhino, I'm going to build the, I'm going to design the rest of what my display will look like. That'll hold all the electronics in the back and maybe allow either to mount it on the wall or have a little kind of kickstand for mounting or setting on a shelf. And so, yeah, let me show you a couple things and then we'll try lighting it up. So I'm going to set this here, clear off some things. So first of all, these panels were the best fit. These two panels together were the best fit that I could come up with for this shape. So it fully covers all of the parts that I need to illuminate, and you can see it's also a little bit big. So my frame that's going to hold all this will need to accommodate that, just be a little bit bigger than this. And that'll also give me some space to hide some of my ports and electronics. And on the topic of the electronics, one thing about the matrix portal is that it plugs into, these are standard panels that are used for jumbotrons and Times Square advertisements and stuff like that, billboards. They have standard placement of the data lines. There's a bunch of data lines. And our matrix portal actually plugs directly into that, but that means that it hangs off the edge a bit. And so I wanted to be able to maybe tuck this back somewhere else or put it into a little box or something. And so I made a little breakout cable. And if you didn't know, we sell these really cool DuPont connector wire cable sets and cable ends. So you can use these. They have a bunch of different sizes. These are, I don't think either of these are the exact, one of these might be the 10 by 2. But you essentially can get our multicolor IDC or DuPont wire sets that don't have any headers on them, and then strip off, I needed 10 times 2, so 2 sets of 10 of these. These actually happen to come in 10, the brown through the black here is 10 of them. So if you strip that, plug it through on one side, the other you get a male, female, or pin and socket cable that'll work perfectly for this. So I built that, and that means that I can plug the matrix portal. It's as if it's plugged directly in there, but it'll let me get a little extra clearance back here, and I won't have to make the frame as wide. So that might end up being the solution or not, we'll see. And then these 2 panels are connected together with another ribbon cable. You could use this kind of cable to connect these, except you need to adapt one of them to socket and the other to pin. These are normally both socketed. And then I've also got power running to this externally. So I've got a 4 watt or a 4 amp 5 volt battery, or rather wall wart. And I'm just looking for that. Where'd you go? I see you there. I see you there. There you are. So that will give us power to the panels, and then I'm using just a wall wart USB-C to power just this board, just the matrix portal. And some projects you can do without needing to have external power. This one I'm probably, just because I'm making it bright enough and it's 2 panels, I'm probably always going to need the 2 of those. So this is, let's see, what's the top of this thing? This is. So this is the animation that I've got started just to test this out. And you can see I need to make something to hold this nicely. I don't have a good way to hold it nicely right now. But you can see here, I've still got some, I screwed up one of my dimensions basically. So this is the animation pattern doesn't actually fit this quite right yet. I need to scale it down a little. I wasn't accommodating for the extra gap there. But what that means is that I can isolate just some of these little sections here. And if we set the panel on here, pretending that that's all lined up perfectly for a moment, you'll see now we're going to get some really cool light up effects. Probably you don't want them blinking this much, but I'll make that something that's controllable. And the little light blocker also gives me some nice diffusion. So it doesn't, you don't really see the sections bleeding into each other thanks to the blocker, but it also means that that little 1/8 inch gap is enough that we don't see dots back there, which kind of ruins the effect. So we don't want those dots, and it turns out just a little 1/8 inch blocker here works pretty well for being able to separate that out. So that is my update on that. I'm going to try to finish up the design of the enclosure for it, as well as get those graphics to fit just right. And then in code, the way I'm doing it right now, I showed this last time, is I'm just using a tile map. So I have a bitmap. Once I get the dimensions of that worked out properly, I can just copy and paste it and then show and hide different sections of it to make it blink. Could even do sort of thermometer style meter graph, gradual kind of stuff. Maybe animate those a little bit to move, which would be kind of cool. I had thoughts of, I think Lamora suggested at one point, maybe doing colored lights back there. I'll try that again, but it's working. The color in the inherent to the graphic works pretty well. So, oh, I just killed this. There we go. It didn't like me touching that. I was going to try to scale. There we go. Try to focus that. So when I get my graphics worked out, you'll see that that lines up well. It's pretty cool. Gives a nice effect. So that's my update on that. And so I'll be working on a guide for that. Now the nice thing is you could, even without having an actual LCARS from the show, you could print on, you could print color on an inkjet and get, I think, a similar effect. So the fact that you're able to block it, block the light there, means that you could probably work out a similar thing and use some spray adhesive to set it inside of a piece of plexiglass. So get that lined up again. There we go, and there's the LCARS. All right. Let's see if anyone's got, by the way, if anyone has any thoughts on the cabling, plans for capacitive touch. Someone asked, no, I don't think I'm going to do any complications. If I can just get it looking good as a display, I'm going to call it done. But it would be a cool upgrade. I don't know, you might be able to do some, yeah, I'm not sure. I'm not sure how you'd go about doing touch on this. It would depend on the frame you're putting it in. Maybe you could get a large resistive screen to put over it. But yeah, that's a good question. But I'm not going to be making that one any more complicated than it is. Custom cables questions. Yeah, let me show the products that I was talking about for making those. I asked for these. This was like years ago. I asked Lamore, hey, could you carry these? Because I'm always making little custom cable things, and I'd love to have a variety. So she got them. There's, let's see, let me find that. Oops. Now what have I done? Ooh. Go back to Adafruit here. DuPont might be the phrase that pays. No. IDC. What do we call these? Let's see. If anyone finds them in the Discord, that would be great. Let me move my Discord over here. Sorry. So someone asked about the wires behind the cells in a matrix, 2 small wires behind the cells. Oh, for capacitive touch. Yeah, that's a good question. That work. Okay, getting closer. IDC floppy ribbon cable. I might be able to get there from our jumper. Do we call those? Whoop. So we've got these ones that already have a single plastic end on each one. That's what we've always had. But getting these bare ones is the key for rolling up your own. So raw jumper wires, male, female, that's what I'm using here. Pin and socket, and they come in a couple different lengths. And then I think, let's see, yeah, so housing, we're calling them housings. So small dual row housing, we might also have large dual row housing jumper cables. Those are what I use, and so either end, either the pin end or the socket end goes into that and clips. You can even use a tiny screwdriver or other pick to remove one if you've got to change how you've got those set up. But yeah, if you get a little set of these, you can make your own, roll your own wires like I did, or cables there like I did. Oh, that image doesn't want to show. Let's bring that back. Here you go. Yeah, so that, if you watch that one, that new products video that's in, yes, from 2016, that was a while ago, that'll give you all the info you need on those. So I just have a little box full of all the different sizes of those. When I need to make something, I can. In fact, I helped my buddy Brian, who was building a real R2-D2. He's part of the R2D2 Builders Club, or whatever that officially recognized organization. He just needed an extension cable for R2's eye to a microcontroller or something, and so I used some of these to build a very specific type of connector. All right, and in fact, you know what? Speaking of products, new products, and actually I want to cover a couple of new products that I showed last week, so very slightly old products, but not all that old really. Let's jump to downshooter here, and there. So here's some things that I covered last week, I think, but didn't have all of them in stock. So I got in some of these really nice, let me change the focus there. There we go. Connectors. So we have a bunch of these different snap action connectors. And I wanted to show one in action. So this, you can see, this takes 2 wires in and gives you 2 sets of 3, so 6 out, but it's color coded. So whatever wire is coming into this orange side is going to be replicated on these 3 here. So if I take another pre-stripped stranded wire, works really well. Click that down, and now that's not coming out. Really secure, and those are now connected. Same over here, I'll do that again. So I've got one of these, click, and now we get a nice force multiplier there. So this one will do 3 different wires to triple them. This is 5 1-to-1. These are just 1-to-1. And this is 1-to-5. So I think that's it. I think those are all the new ones that we got in of those. So I wanted to show those so you could see what they looked like. Now I have them on hand. And then also wanted to show I got the Neo Feather S2 Blingy. That's the header pins that come with it. There's the actual feather. So here it is. Make something unexpected from unexpected maker. This has a USB-C connector on it. I can go ahead and give this power. This is as much as I've done with it so far, which is just power it on and see that it works. And it's also got a nice little demo because it has a set of NeoPixels right in the middle there. So it does a little hello for you when you first plug that in. Oh yeah, and thank you. Over in the Discord chat and YouTube chat, George Graves has posted the links to those different snap action wiring connectors, block connectors that I showed. And this one too, this cool new feather. So those were the new products that I got that I wanted to show. And I'll demo some of those other ones in the future once I've used them a little more. And then looking at new products this week, if we head up to, here we go. Scroll down just a little bit. So this one, this actually, I don't think I mentioned this one last week. I don't have one of these yet in stock. Oh, I have an extra face on top of my face. Let me get rid of that. There I am. So this is a snap action connector buckle, pack of 2, orange DF24. So this allows you to connect some of these snap action block connectors side by side, which is pretty cool. It's like a modular system. Really good if you're doing installations, Burning Man, theater, lighting stuff, Halloween, holiday things, any kinds of big installations, particularly using audio cabling, any kind of NeoPixel stuff you're doing. These are going to make life easier and allow you to connect these side by side by side. Pretty cheap too, 75 cents for a pack of 2. Then another one that is new this week is the 16:9 Charlie Plexed PWM LED matrix driver. It uses the IS31FL3731 driver, and this has been STEMMA QT-ified. I believe we had this before, but now we've got the Stemma QT version. And this is a driver board that you can plug in any of the single color matrix LED boards. So you can see them, actually, I'll just hold them right there. You can see we've got these 16 or 9 by 16 LED single color. This is not RGB stuff, single color. And you can put these together, solder it in place, or use headers if you want to change the colors out. And now you can drive it using Stemma QT and do all kinds of cool Charlie plexed matrix LED effects. These are the tiny, tiny, teeny little ones that are soldered on the diagonal so that they fit as close together as they can and look super cool. Let's see, what's next? We have the 3 volt to 5 volt level booster in Stemma QT. So last week we showed the other way around. So again, if you're using a microcontroller that has a different logic level than your devices that you're plugging into over Stemma QT, over I2C, now you can go in either direction. You can have 5 volt boards going to 3 volt sensors. You can have 3 volt boards going to 5 volt sensors. So those are all options, and now we have the complementary pair. So maybe just pick up some so that you're ready. Next one we have here, this is the Stemma QT multiplexer, now 4-channel version. So we had the 8-channel version before. This is using this PCA 9546 chip, and this allows you to plug in a microcontroller into one port and then plug in 4 I2C devices that share the same address. And normally you can't do that, but this fixes it. This allows the board to poll those devices, ask for their information, and then send it all up to the microcontroller, even if all 4 of those devices have a shared I2C address that can't be changed. This is a nice way to solve that. And we had a version that did this with 8, but some people said, hey, I'd like a version that just does 4. You can save a little bit of money and get this 4-channel version instead of the 8. And then we also have, just instead of this Stemma QT version, we also have on the way the just pin solder version that you'd mount to a breadboard or to a permaproto. And that, I believe, is your new products. All right, what else? I think that's it. Does that cover everything? I wanted to say thank you, everyone, for stopping by and hanging out. And I will be taking off a few days for the holidays, and I hope you will too. And I believe we're not shipping Monday and Tuesday of next week. I will not be doing my product pick show on Tuesday. I will, however, be back right here at this time next Wednesday to do another John Parks workshop in this very special Ask an Engineer time slot. So come on by. And in the meantime, I wish you a very Merry Happy, if you're celebrating any of the holidays, Merry Christmas, Happy Hanukkah, Kwanzaa, anything that's happening, Larsmas, whatever you want. Lars and I want to wish you a very, very happy holiday season. And that's going to do it. So thanks so much for Adafruit Industries. I'm John Park. That's Lars, and we will see you next time. Bye-bye.